Hey guys, welcome to this video lecture series on the subject of energy technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In this video, we are going to start a new chapter of energy efficiency in thermal utilities. Well, this chapter is being divided into 4 different parts, such as fuel and combustion. Then it is followed by the steam system, and we will learn about the insulation and refractories. And lastly, we will conclude this chapter by waste heat recovery part. So let's get started with the fuel and combustion. Well, this fuel and combustion is not new term to us. In 10+2 course, we must have studied this fuel and combustion, or you have studied this in your diploma courses. Well, in a first year, this section is being covered in the subject of chemistry, while in a second year, the subject of material and energy balance computation covers this topic of fuel and combustion. So, it is not that much difficult to understand that how important is this fuel and combustion to one chemical engineer. We cannot imagine our life without the fuels, since these fuels are the main and major sources of energy for us. So, let's define the fuel. Well, on a practical life, we can define fuel very easily. But when it comes to technical definition of fuel, it is a bit tricky. So, let's see what is the definition of fuel. Well, fuel is the combustible substance. Now, here the word combustible means any object or any body to get fire up, or it is easily burned. So, a fuel is the substance which is combustible in nature. It burns in the presence of oxygen and release energy in the form of heat energy. So, this is what the complete definition of fuel. We revise it one more time as fuel is a combustible substance. It burns in a presence of oxygen and releases heat energy. So the word presence of oxygen is very important and very necessary to write the definition of fuel. Now let's move to the second definition of combustion. Well, combustion is the chemical reaction involves fuel and oxygen. This reaction is exothermic and rapid in nature. It is process of converting chemical energy of fuel into heat energy. So, we can define the combustion as the chemical reaction that involve fuel and oxygen. So, the process of burning fuel is known as the combustion. So, now let's move to the fuel and understand what are the different fuels and what are the properties of this fuel. Well, the main combustible chemical material in the fuel are generally carbon, hydrogen and very small amount of sulfur. So, sometimes they are referred as hydrocarbon fuels with chemical formula of CXHY. It can classify into 3 categories on the basis of their physical states. Well, any body or any object is available in 3 physical states: solid, liquid and gases. So, the fuels are also available in solid form as the coal. They are also available in a liquid form as different petrochemicals and different fuel oils. Well, these fuel are also available in gaseous form as the natural gas or LPG or maybe methane. So, this was the very simplest classification of fuel. We classify fuels so that we can understand them better and utilize their maximum chemical energy potential. So now let's see some of the properties of this fuel. Well, the first property of fuel is calorific value. So we can define calorific value as calorific value of fuel is the total quantity of heat liberated when 1 unit mass or volume of fuel is burned completely in a presence of oxygen. Well, we have already understand this calorific value in our introduction part. We have said that for a family of a 4 person, the 12 kg cylinder of LPG will run for 2 months for cooking applications. If I have to put wood on a same application, I will be ended up by consuming around 50 to 60 kg of wood. So that indicates the wood has a lower calorific value, because for the running time of 2 months, this wood will require around 50 to 60 kg, while the LPG will require only 12 kg. So we can say that the LPG has much higher calorific value than the wood. So ultimately, the calorific value of a fuel is the capacity of that fuel to supply heat. The solid fuels have low calorific value, while the liquid fuels have moderate calorific value, and gaseous fuel such as LPG and other petrochemical gases has the highest calorific value. Well, this calorific value can be divided into two parts. One is the higher calorific value and another one is the lower calorific value. For the exam point of view, this definition of calorific value is very important, because the examiner can arrange around 3 to 5 different definitions and combine them to put a 5 or 3 marks question. So let's understand what is the higher calorific value. It is the total amount of heat produced when unit mass of fuel has been burned completely and the product of combustion has been cooled down to room temperature. Well, this definition of high calorific value is very much same as the calorific value, but the change is that the product that being produced by the combustion is need to be cooled down at a room temperature. Let's read one more time this definition. It is the total amount of heat produced when unit mass of fuel has been burned completely. Up till now it is perfectly fine and it is similar to the definition of calorific value. But from here you can read it on the screen. The product of combustion have been cooled to room temperature. So when the product of any combustion reaction are cooled to room temperature, their energy is known as the higher calorific value. Well, this higher calorific value or gross calorific value is the calorific value which accounts into the latent heat of vaporization of water. So now let's move to the second type of calorific value, and that is low calorific value. Well, it is the net amount of heat produced when unit mass of fuel is being burned completely and all the products are allowed to escape. So this is the main and important line for this definition, that the product of combustion reaction are allowed to escape. The lower calorific value is the amount of heat energy that is available for actual uses. So this was the all definition and all the properties of fuel related to calorific value. Now let's move to the next property, and that is specific heat. Well, specific heat also not new to us. We have already studied this definition in thermodynamics. So it says that specific heat is the amount of energy needed to rise the temperature of 1 kg of a fuel by 1 degree Celsius. The specific heat determines the how much electrical energy is takes to heat up the fuel and to rise its temperature to desired value. Well, its unit is kilocalorie per kg into degree Celsius. Now let's move to the second property, and that is ignition temperature. Well, we can define ignition temperature as ignition temperature is the lowest temperature to which the fuel must preheated so that fuel start burning smoothly. Solid has a more ignition temperature while liquid has the moderate ignition temperature, and gases have lowest ignition temperature. Now let's understand the next property of fuel, and that is flash point. Well, the flash point of fuel is the lowest temperature at which a fuel can be heated so that the vapor gives off flash for very small time when an open flame is passed over it. So whenever you supply an energy or supply a flame to the fuel, it gets burned and it generates vapor that necessarily flashes for a few minutes or a short time of span. This point or this temperature is known as the flash point. Well, typically petrol has the flash point of around 44 degrees Celsius. Now the next property of fuel is the pour point. The pour point of fuel is the lowest temperature at which fuel will pour or it will flow. It is very rough indication of the lowest temperature at which fuel or oil is readily pumpable. So this pour point also indicates the viscosity of fuel. Now let's understand the next property, and that is non-combustible matter of fuel. The non-combustible matter does not take part in the combustion reaction. After combustion, the non-combustible matter remains in the form of ash. The non-combustible matter also reduces the heating value of fuel, and it increases the additional cost of storage and handling. Well, the solid fuel has the highest amount of non-combustible materials, while the liquid fuels has moderate amount of non-combustible material, and gaseous fuel has lowest amount of non-combustible materials. Well, this is the main reason behind the gases having higher calorific value, since they has lower non-combustible materials. Now let's move to the next property, and that is density. Density can be defined as the ratio of mass of fuel to the volume of fuel at reference temperature. Density is being measured by the instrument called as hydrometer. You can see this instrument in the image which utilized for the measurement of density. The density is used in the quantity calculation and estimation of the ignition quantities. Well, its unit is kg per meter cube. Now, the next property is the specific gravity. It can be defined as the ratio of weight of given volume of fuel to the weight of same volume of water at the given temperature. The specific gravity of water is 1. Specific gravity can also be measured by the instrument hydrometer. Since the specific gravity is the ratio, it does not have any kind of unit. Here in this table, you can see the specific gravity of some of the fuels as light, diesel oil and petrols. Now let's move to the next property of fuel, and that is viscosity. Viscosity of a fuel is measure of its internal resistance to flow. If oil is too viscous, it becomes difficult to pump and it ultimately becomes tough to operate this kind of fuel. So low viscosity fuel are always preferred. The viscosity also depends on the temperature. As the temperature increases, viscosity decreases. The unit of viscosity is stock or centistock. The measurement of viscosity can be done by different viscometers. Now the next property is the ash content. The ash value is related to inorganic compound in the fuels. These are maybe a salt of sodium, vanadium, calcium, silicon and iron. Typical ash value is in the range of 0.03 to 0.07%. Excessive ash in the fuel can cause fouling and decomposition of the combustor. Now the next property of fuel is the sulfur content. The amount of sulfur in fuel depends mainly on the source of crude oil and refining process. The normal sulfur content of diesel is around 0.05 to 0.25%. So this concludes the properties of fuel. Now in a next video, we will understand about storage and handling of fuel, and we will see the combustion part as well. Till then, keep watching, keep learning. Thank you.